Good afternoon, everyone. Welcome to our webinar, Revolutionizing Structures with Cobiax Technology, organized in collaboration with Engineers Ireland and Young Engineer Society. Today, we're excited to dive into the innovations and applications of Cobiax technology in construction. Our guest speaker is Nimete Spahiu, a structural engineer with Cobiax Germany, with extensive expertise in voided slab systems. Nimete brings a wealth of knowledge from her background in civil engineering at the Polytechnic University in Tirana, as well as her hands-on experience in design softwares like Technostructures, Revit, and robot structural analysis. In this session, Nimete will walk us through the design principles, recent advancements, and real-world case studies showcasing the success of Cobiax system. We'll wrap up with a Q&A session, so feel free to type any questions you have into the chat during the presentation. Over to you, Nimete.
Yeah, thank you very much. So I am Nimete Spahiu. I am from Albania, but I work for Cobiax Germany. So today I'm going to explain how to calculate a Cobiax voided slab and to make a general presentation, introduction of the Cobiax voided slabs. So I will start. Our webinar for today has 4 contents. The first one is the technology introduction. As we know, the most used material in our slabs today is the most used material in buildings is the concrete, but a large amount of it is used for the slabs. But as we know, as civil engineers, in many parts of the slab, the concrete is not necessary. It is just heavy. So for this, we have a solution that it is Cobiax. But what Cobiax is? Cobiax is a void former system made of 100% recycled plastic. With Cobiax, you can replace about 35% of the concrete. Due to this, you will have the dead load reduction. We have a great impact also environment. Based on this, we have about 20% less CO2 emissions by using Cobiax. Since the slab will be a light-weighted slab, so the loads will be reduced and we will have about 15% less reinforcement. So we have savings in concrete and we have savings in reinforcement by using Cobiax. Cobiax is suitable for the slab thickness from 20 to 80 centimeters. Here is a product overview. There are available for Cobiax 2 types of the product. This is the Cobiax CLS. Cobiax CLS is the most innovative product. As you see in photo, the Cobiax consists on 2 half shells, square in the plan. In total, we have 7 different half shells of the Cobiax CLS. And we use Cobiax CLS for slab thicknesses from 20 to 80 centimeters. Also, we have another product that it is called Cobiax SL that we have used before, just the Cobiax SL. Cobiax SL, as you are seeing in the photo, is one module of the Cobiax SL consists on 6 void formers and fixing elements. Cobiax SL is more limited. You can use Cobiax SL for slab thicknesses from 22 to 40 centimeters. As I said before, the Cobiax CLS consists on 2 individual components or 2 half shells, one in the top and one in the bottom. Cobiax SL, the installation part consists on 14 individual components, 6 in the top and 6 in the bottom, and 2 fixing elements. Cobiax has over 21 years in the market, so since there, it has been successfully installed worldwide about 20 million square meters with Cobiax voided slabs. There are many engineers that ask us to make the difference between the voided slab, other voided slabs, and Cobiax voided slabs. Just here is an example about the waffle slab. As we know, in waffle slab, in both directions, we put those additional shear force reinforcement is required to afford the shear forces. In case of the Cobiax, we proceed like this. In areas where the shear forces are more than the shear resistance of Cobiax, in those areas we are not allowed to put the Cobiax void formers. And in areas where the shear forces are less than the shear resistance of Cobiax, in those areas we are allowed to put the Cobiax void formers. This is the reason that in areas where we put the Cobiax void formers, we don't need those additional shear force reinforcement, since the shear forces are less than the shear resistance of Cobiax. So we have savings in the shear force reinforcement. As I said before we have had just the Cobiax SL that has been used. I just wanted to show you how this Cobiax SL is very important to install it in the site. You have to follow some rules for that. One of the rules is that the between the void formers from here to here, from here to here, from center to center of the void former, the distance should always be 35 centimeter. And you should always save this space in here. So this space in here should be parallel to the other space in here. But this sometimes leads to many mistakes in the site. This is very important to save this space in here and to put the distance 35 centimeter in all directions, because it will be created this area here that it is highlighted with green. This area is called the X zone. This is the area where is the concentrated the largest amount of the concrete in there. So it is the load bearing area. So due to the mistakes that the workers do in the site, this area is not always created. To avoid this thing, we have our innovative product that it is called Cobiax CLS. As you see in this product, this area is created automatically by the shape of the Cobiax CLS. So this part is avoided, and this brings to the easiest part in the site. And what you have to do is just to put those Cobiax CLS just next to each other without worrying if you are creating the X zone or not. And this is the reason why we have created this Cobiax CLS, and this is the reason why these are the advantages of the Cobiax CLS. So in total, we have 7 different half shells of the void formers. So if we see, here are the 7 different half shells. It begins from 5.5 centimeter till 29.5 centimeter. By combining them together, we create 19 different CLS void formers. As you are seeing here, that will be suitable for different sizes of the slab thicknesses. The SL range, it includes just those void formers in here. As I said before, the SL is a little bit more limited than CLS, because SL is for the slab thickness from 22 to 40 centimeter, and CLS is for the slab thickness from 20 centimeter till 80 centimeter. Here is a short video about the installation part of the Cobiax in the slab. So we lay down the bottom reinforcement. Then we have the half shells of the void formers. We put them together and we create one void former, and we place them in the slab. There are some parts in the slab that doesn't fit one void former, so you are allowed just to cut it in and to use just the half of it, if you want to optimize the number of the CLS that are used. After that, we place the top reinforcement. Then we place those that are calling bonding reinforcement, as you are seeing in here. We lay down the first layer of the concrete. I'm sorry. We lay down the first layer of the concrete. So we lay down the first layer of the concrete. I told you that we place those bonding reinforcement in here. Those bonding reinforcement are very important just to join the first layer of the concrete with the second layer of the concrete, because the pouring process will be in two layers due to the fact that this will not allow the Cobiax void formers to float. That's the reason. Then we wait for 2 or 3 hours till the first layer get dry, and we lay down the second layer of the concrete. This is just to make a comparison between a building with Cobiax slab and a building with solid slabs, just to see the difference between them. So the advantages of using Cobiax at a glance. So we have advantages for the floor slabs. If we use Cobiax, we can do a thinner slab. If it is planned to be a 30 centimeter solid slab, we can do without fear a 28 centimeter Cobiax slab, and we will have the same deflection in there. So by doing a thinner slab, we will have more heights in the room, and the usage of room will be improved. It's the advantages for the overall construction. Since we have a light-weighted slab, because we will replace the concrete with Cobiax void formers, we will have the load reduction in the whole building. So the load-bearing elements will be optimized. We will have the dimensions of the columns that will be reduced. The foundations will be optimized, and so on. For the foundation, as I said, we can do smaller foundation since the overall load will be reduced. And for the environment, we have a great impact environment. We have an EPD certificate for that. So we have about 20% less CO2 emissions. So the second content is about calculation procedure using an example. So just for you to know, we don't place Cobiax void former all over the slab. We place just in areas where the shear forces are less than the shear resistance of the Cobiax. So, but in generally the slab, the Cobiax slab design will be very similar to a solid slab. Just by taking into account some things like the load reduction, the stiffness factor that will change, and the shear force. The degree of occupancy with the void former varies from 50% to 80% of the total slab area. There are many engineers that ask us which is the software that you use when you design a Cobiax slab and so on. They are a little bit skeptic. They are a little bit afraid of how to design a Cobiax slab, but they don't need to be afraid, because they can use what they have always used. Since the design of a Cobiax slab is very similar to a solid slab, they can use the same software that they have always used. We have a very important tool in our website, and this tool will provide all the necessary information that they have to change in their software so they can calculate a Cobiax slab. And this tool is very fast. Just in 2 minutes, I will explain it to you. So if you go in our website, Cobiax International, just like this, and then just press it. Here you have the opportunity to choose one of the languages. I will choose the English one. Here is an icon that it is called CQL, and it is our tool that helps you, provide you the necessary information to do the design part of the Cobiax lab. Here you are in the CQL. You can change the language in here, since it is a German brand. Here is the Deutsch, the German, and here is the English. You can choose the English one. And you have just to put the email address and the password and just log in. Here you have the possibility to choose the new project, the name of the project. I am calling it test, and here Ireland, and just press OK. And in the end, it will appear this, what I created. Here you have the possibility to start a new calculation. Here you can put the core data. Here is the position of the slab, in which floor. I am just supposing that we have typical floors, and I will press just typical floor. Here you can put the slab thickness. I am just supposing that it is 30 centimeter. Here is the possibility to choose in situ or semi-precast panel. I will choose in situ one. Here is the standard. Standard is Eurocode 2 with German annexes or Eurocode 2. I will choose the Eurocode 2. Here are the fire resistance parameters. When you choose Eurocode 2, this one will be chosen automatically. Here are the fire resistance classification. Here I wanted to mention you something that a Cobiax slab during the fire reacts the same as a solid slab. So you can choose whichever you want, because there are, for example, those slabs that are with polysterol. The durability will be, the duration will be about 20 minutes. But here you have the opportunity to choose how much you want till 240 minutes. I will choose this 90 minutes. Here is the static system, one-way spanning, two-way spanning. I'm just supposing that we have this casing here. Here is the bar diameter of the lowest reinforcement, the bottom reinforcement. So I am just supposing that I have V12 each 10 centimeter. I will press OK, and I am done with the first page. Now in the second page is the geometrical part, the cross section that I will create. So I am supposing the required geometry are the concrete covers in the top and in the bottom, and the reinforcement layers in the top and in the bottom. I am just supposing that I have 3 centimeter, the concrete covers in the top and in the bottom, and the reinforcement layer that are 2.5 and 2.5. Because I have V12 in each direction, so it will be 2.4, 0.1 will be like a tolerance. And then after I put the concrete covers in the top and in the bottom, I have the possibility to choose the void formers. Here are the 2 types of the void formers that are available, the Cobiax CLS and Cobiax SL. Here are the Cobiax CLS and here are the Cobiax SL. Those that are showing with black are that we can use due to the geometrical part. We should always choose the biggest one. It's always tendency to choose the biggest one because the savings in concrete will be more if we use the biggest one. So I will choose this one. I press OK, and it fits perfectly. So I press save. So I will save those input data. Here are the fire resistance. If it is right in here that the fire resistance proof is provided, then we are okay with the fire resistance. If it shows with red, we are not okay, and here those messages will show you which is the problem. Maybe you have to add something in the concrete cover in the bottom, so you can reach what they want to that the fire resistance proof to be provided. So I will pass in the third tile. And the last one, here are the parameters of the concrete. Here are the concrete strength class that you can choose whichever you want. You are not limited. Here is the density of the concrete, and here is the statical effective depth that will come automatically. Here you have to put the flexural strength rebar. Since I have V12 each 10 centimeter, then the flexural strength rebar of the reinforcement area will be 11.31. And I am done with this. So here I will get three very important values that you can use in your software so you can start the calculation. The first one is the load reduction. So since you replace the concrete with Cobiax void formers, you will have a load reduction, and in this case is 2.27. The second one is the shear resistance. A very important issue is about the shear resistance. As I said before, if you remember, we will put the void formers in areas where the shear resistance of Cobiax is more than the shear forces. That's the reason that we need this value in here. And the third one is the stiffness factor. As we know, logically, the slab will not be as stiff as a solid slab. So, and this stiffness, this factor, we can get it from our tool that it is in CQL. Those data, the input data and output data that we get, we can also have them in PDF. So you can export PDF, and here you have the characteristic of the Cobiax slab, the values of the void formers, the cross-sectional structure with the concrete covers and so on. And then here are the results that are the load reduction, the concrete savings, the CO2 emissions also are in here. Here is the cross-section and so on. And the second one is the that we can export the cross-section of the slab. So here is the cross-section of the slab. We have a 30 centimeter slab, concrete covers, reinforcement layer, and the void formers. So now I will go to my webinar. So as I said before, so this is what you have, just 2 minutes work in the CQL and you are done, you provide the values that you want. Then how we start the calculation part. So I am supposing that I have a point supported flat slab 10 to 10 meter span. So what I have to do is that I apply the load reduction over the entire slab area. That load reduction that I have in there that was 2.27, I apply it over the entire area. And I go in my software program, whichever you want, and I change the stiffness factor that I get from the CQL. And this is the first calculation run. Here is just an example, just for you to consider that it has happened in Cobiax slab that the slab thickness was 3 centimeter less, a Cobiax voided slab that was 35 centimeter, and the solid slab 38 centimeter, the same slab, and they have the same. They have the identical deflection, even though the slab thickness was reduced by 8%. So after we apply that load reduction all over the slab, and after we change the stiffness factor, we run the calculation. And after that, we proceed like this. We put a limit of the shear resistance of the Cobiax that we are supposing that in this case is 63. And we proceed in our program like this, that where the shear forces are more than this limit, that it is 63 kilonewton per meter of the shear resistance, those areas will look like red areas, like you are seeing in here. And those areas, we will let them as solid areas. And those areas where the shear resistance is more than the shear forces, than this limit that we put, then we will let them as blue areas. And in those blue areas, we are allowed to put the void formers. After we run the calculation again, we will see that those red areas are solid areas. Since they are solid areas, we don't have here the load reduction anymore, because we have load reduction just in areas where the Cobiax is placed. So what we have to do is that just in those areas, those small areas in here, here, and here, we have to apply this load that we reduced before. That was, for example, 2.7, I am just supposing. And then run calculation again, and then we will see that the areas that bigger areas, red areas will show, and those were the last one that we will not change anything anymore. So those red areas will be the solid areas in our slab, and those blue areas will be the areas where the Cobiax void formers will be placed. And the condition is that the shear forces in areas where the Cobiax will be placed should be less than the limit that it is the shear resistance of Cobiax, and that this shear resistance of Cobiax we get from our tool that it is called CQL that I showed you before. And this is how a Cobiax installation plan will look. And the occupancy rate in this case is about 65% of the slab area. As you see, those white areas in here are solid areas, and those are where the Cobiax void formers will be placed. Economic benefits. Many of people ask us about the costs. And I want to mention that you can't refer just, they ask us for enough offer, we made the offer, and they say, they just refer to the price of the product, but it is not just the price of product that determine the costs of the Cobiax slab. So I am supposing that this style in here, this strip in here is the cost of the solid slab. Of course, that we have costs about the delivering, the costs of the transport. We have the cost. Here is the cost of the transport and the cost of the product. Here is the cost of the assembling and installation part. Since I will show you the assembling and installation part, you will see by yourself. Here is the additional cost for casting on 2 working steps. As I said before, we should always pour in 2 layers because otherwise the void formers will move from their place. But we have many savings. We have concrete savings due to the Cobiax void formers. We have concrete savings due to the reduction of the slab thickness because we can provide a thinner slab by using Cobiax. We have replacement of the support cages. As we know, in solid slab, we need those support cages to carry that top reinforcement. But in this case, we don't need the support cages. Are the Cobiax void formers that play that role? We have savings in punching reinforcement. Since we have a light-weighted slab, we will have less punching reinforcement in the slab. So that's the reason that we have savings in the punching reinforcement. We have savings also since we have a load reduction, we will have less loads, we will have less moments, and we will need less reinforcement in bending reinforcement. So those are the reduced, this is the strip about the reduced cost of the Cobiax slab. And if you compare it with the cost of the solid slab, there is a difference in here. Optimization potential, what does we mean with this? So we have a product, there are many products that looks like ours, but our product, I will send who is interested, our product has German approval, that it is very important, that technically it allows you to use the Cobiax void formers. Also, we have a certificate about the environment, the EPD certificate. And I think that the environment today is very important, and it will come one day that it will be a condition to have such a certificates in your building. And in this case, if you use Cobiax, this will grow the value of your property if you use Cobiax in your property. So this is what we mean with optimization potential. The last one is the sustainability. As I said before, Cobiax void formers are made from 100% recycled plastic. We can save about 35% concrete since we save, and 15% the steel. Since we save the concrete, less cement will be produced, so less CO2 emissions will be free in the air. So this is the great impact that we have in environment, and we have about 20% less CO2 emissions. And also we have additional material savings that can be achieved by building with Cobiax. Also, a very important issue is about the recovery. After a building is demolished, you can reuse it. The Cobiax void formers that are left from that building, you can reuse that, and this can be just by a simple process of the float sink method. Just put them in the water, the concrete will go down, and the Cobiax will go up, and you can take them and reproduce them and reuse them. An important issue is about the cable ducts and insulation parts. For those ducts, for those cables that the diameter of them is more or equal to 25 millimeter, you can proceed like this. So you can let the solid strips in there and place them in there, or if the diameter is less than or equal to 25 millimeter, you can place them between the void formers, like this example in here. And the last thing that I wanted to show you, just to have a better view of the if you go in our website, in our YouTube channel, there are very important video about the Cobiax CLS, how to assemble and to install it in the slab. Just for you. And here it shows all the process, how to install it in the slab. So if you go in our website, here is our YouTube channel, just press it, choose the English one. And then here we have a video about the assembling and installing the Cobiax CLS. As you are seeing here, those are the half shells. It's very easy to assemble them. Everyone can do it. So first we lay down the lower reinforcement layer. This is how we lay those void formers, just next to each other. Very easy. One yes and one no, we have to stick them together just so the workers will not move them from their place when they walk above them. So the X zone is fitted automatically by the shape of them. This is the top reinforcement layer that now is laid down. Those are the omega hooks or bonding reinforcement that I said to you that we put them, we hang them over the top reinforcement, and it will serve to link the bottom layer with top layer of the concrete. Two of them in each X zone. We have just to hang them in the top reinforcement. It's very easy. So we put the first layer of the concrete. Vegetation, as we always proceed in solid slab. Then the second concrete layer. After it has been the first layer dry sufficiently. And we are done. Like this. So if you have any question, anybody, you can ask.
Thank you so much, Nimete, for sharing those valuable insights.